Alright, let's begin. So for this video, we are going to be talking about the alarmables. So alarmables we have the registry and deregistry. We have an alarm cancel function, which I'll talk about a bit more later. We have an attorney, just like we do with all the other expos. We have 8 different alarms that the user can override. A trigger alarm call, scene registry and deregistry to be accessed by our registration requests. And we have the setting of the map reference and getting that reference, because unlike with the draw and update, alarmables are stored using a multi-map. And finally, we have the struct for the alarm storage. This stores all the necessary data for each alarm. And then we have an array to store however many alarms we have set up. So in the case of this, we have 8 alarms, so it is an array of size 8. When it is time to create an alarmable, we will populate each of those 8 spaces in the array. We will set the ID to be the given ID at I. We will set the state to be deregistered and create our registration and deregistration requests. We have the 8 alarms for the user to define, and we have our assert guards for all of our registration. Because we're using an array, we can find the location for the given alarm by static casting our enum into an int, and that will update when it's time to register. That will pass through the time for the given alarm for it to go off, and then we will submit the request back into the scene to be handled during the update. Well, yeah, to submit the request here, and then during the request broker step in the update phase, the alarm will become registered. And then for deregistration, we submit the deregistration request so that once again, it would be processed at the broker at the start of the update for the scene, and we set it to pending the deregistration. For scene registration and deregistration, we will call the alarm pass-through registry and deregistry. So to pop back into the scene attorney, the register and deregister for the object, which will pass it all the way through to our alarm manager. For registry and deregistry, we use the map iterator both to insert it into the map and also to erase it. When we insert it into the map, we are inserting it wherever it fits based on the time that the user requests. So when the user gives a time, we get the time from the time singleton, and we add the user's requested time onto that, and that represents the key. And then beyond the key, we will create a pair of alarmable object and the ID to trigger it. And because we are storing the iterator in our OBJ, in our alarmable object, when we deregister, we can deregister based on the map reference of the alarmable and the alarm ID. So to jump back to here. So instead of requesting deregistration, the user could attempt to try and cancel an alarm. Because the user has, in most cases, the user has no way to know whether an alarm is still active or not without trying to check the registration anyway. They would be doing the same if statement, so I made this alarm cancel just to streamline the process for them. So for alarm cancel, if the user wishes to submit an object's exit, but they don't know if an alarm on the object is still active or not, it will check the ID that they request to cancel, and if that currently is active, it will immediately send it to pending deregistration and deregister it, similar to how we have the deregistration on the trigger alarm. Speaking of the trigger alarm, when it's time for an alarm to be triggered, we will first, again, assert guard, make sure that it is currently registered, and then after that, we will immediately deregister that alarm. We are deregistering the alarm at that ID immediately so that if the user wishes to have a looping alarm, their alarm call will not cause a crash. So if the user wanted to loop alarm 5 is now deregistered. By the time we call alarm 5 here, they will have the ability to register it again. For the alarm manager itself, like I said, we are using a multi-map with a float key and then an alarm pair object behind it. We have the registry, deregistry, and processing of elements. I already went over the registry and deregistry. When it's time to process the elements, which is done as one of the last steps of the update phase in the scene, it's done right here after inputs but before before updates. When we process them, because we're not certain how many alarms are going to be going off, we have a little while loop here that goes while our multi-map is not empty, and we also have the first item in our multi-map be having a time less than the current time in the time singleton. So if this time is less than the time singleton time, that means it is ready to be, the alarm is ready to go. So we will store that alarm, we will remove it from the list, from the multi-map, excuse me, and then we will call that trigger alarm I just showed off over here. And we are doing this as a while loop because it is possible for multiple alarms to be set to the same amount of time. So once one goes off, we once again check the beginning of the list, and if the time is met, we set off another alarm, and we continuously repeat this process until we either end up with an empty map or we find a time that has not yet occurred based on the time singleton. And then just to showcase the registry and deregistry, both of these are calling the registry and deregistry through the attorney. And then we have the game loop alarm to pass through the trigger alarm and the map reference setters and getters to the alarmable. So if I were to quickly show off this frigate, which has every single alarm registered to it, we are going to have a looping alarm number 6. So alarm 6 is going to be looping, and we have alarm 0 deregistering alarm 7, just to show that we can do that. So as you can see in the output window, we got 6 being triggered, 6 is being triggered again, 6 is constantly getting triggered constantly. And as the time goes on, so because it's 2, so 2, 4, 6, 8, 10, 12, notice how alarm 7 was being triggered for 10 seconds. It's been beyond 10 seconds and alarm 7 has been triggered because the alarm 0 has deregistered it. So this is a case where we know the alarm hasn't been met yet, so we can deregister it. For submitting the exit, I could submit the exit while alarm 6 is looping, or I could submit it on the frame that it's done, or I could submit it while alarm 4 hasn't been triggered. Because I don't know, that is where I have all of my alarm cancels. So if I were to be closing this, oh, that did not close properly. So if I were to close this, we have no leak still. And that's it.